forward propagation. And the forward propagation was it essentially implied that we get differentiation of L with respect to W. And that, and only differentiation is formed around the loss function. However, when you learn such kind of forward propagation, it takes too much time, and sometimes it does not work that well. Okay, so at the year of 1986, it turned out that it was impossible to train the forward propagation. But afterward, at the year of a few years later, Jeffrey Hinton developed a method that is back propagation. That back propagation, changed the deep learning world. And since that time on, we are always using back propagation instead of forward propagation. So today, I will start from scratch to explain about back propagation. Okay, it's a very simple and straightforward, and I do not use mathematical expressions. Instead, I use some graphical explanations that is easy to understand. Okay. So let's go to essentially, in summary, I told you guys that let's find a more efficient method to get gradients, and that is backpropagation. And one way of introducing the backpropagation is using mathematics. However, computational graph method is intuitively much more easier, much more easier to understand. So, in this class hour, I will talk about the computational graph method instead of mathematical derivation. If you go to mathematical derivation, it's a very long differentiation from back to front. So then there is a partial differentiation multiplied by partial differentiation and multiplied something and something, go on and go on. So it just make you just knocked out. So instead of that, I will use graph to let you understand what backward propagation. Okay. In order to understand that, let me introduce what computational graph is. And this is a very simple example. Okay. And the graph is composed of multiple nodes. We call these nodes, and sometimes we call these edges. Okay. The arrow is, we call that edge, and the round circle is we call this as a knot. Okay. Let me start from a very simple example to explain about computational graph. Let's assume that you buy 2 apples, okay, and it costs $100 per apple. And how much do I have to pay for that if I buy 2 apples? Okay, and let's assume the consumption tax rate is 10%. Okay, so then we can solve this problem graphically using this process. Okay, you buy, the price of apple is $100, and you buy 2 apples, and that will make it $200. However, you have to pay sales tax or consumption tax of 10%. So then the total amount that you have to pay is $220. Okay, so then we call this is operation. Okay. However, it would be more convenient to pick the numbers out and let the operation itself in the node only. Okay, so let's change this figure a little bit. Okay, then the figure turns out to be like this one. Okay, this one. Okay, so then you are buying 2 apples. And you are drawing some kind of a computational graph, and you just use operations in the circles, in the nodes. Then how you draw the computational graph, you just do it yourself on your notebook. How you draw the computational graph if I use multiplication and multiplication only in the notes. Okay, do it now in your notebook. Okay. Okay.